Hi, this is Mrs. Ziegler, and I'm going to go over your types of forces notes and how to draw free body diagrams. So in your notes, we know that there's two different types of forces. Contact forces, which means that matter is touching matter in order to cause objects to move, such as friction, or non-contact forces, forces that do not actually need to be touching matter in order for forces to be acting on an object. So the first type of force is tension force. So when you look here in your notes, F of T is the abbreviation for tension force, which tension force is any force in which you have that is acting from a rope or a string, generally from hanging or pulling horizontally. But tension force has anything to do with a rope or string. Whereas spring force, which is F of S, is force that's created from stretching or compressing a spring. Applied force, which is F of A, is any force in which a person is pushing or pulling on the object. The gravity force, which is F of G, is force in which pulls matter to Earth. So when you are throwing something and it falls towards the Earth, that's gravity that's pulling down to the Earth. Support force or normal force, which is F of N, is any perpendicular force that is perpendicular to the surface that's pressing on the objects. So that actually causes objects not to go through it. So for example, if something is on a table, the support force or the normal force is the opposite of gravity, and it's equal and opposite, which causes the object not to move. Then the last type of force is friction force, which is F of F, which is a force that opposes motion, and it is always smaller than the actual motion of the object that is moving, and is always against the motion. So for example, in this picture, if this object is moving in one direction, then the opposite direction will be the friction, which will be smaller. So in this picture, which is a picture that also has part of the free body diagram, it shows all the forces acting on the object. You see that stick person is pushing that box. That's the applied force. Gravity is pulling the box down, where the normal force is the force pulling up or pushing up that's causing the object not to fall through the ground as gravity pulls it down. And since it's being pushed against the floor, friction is the opposite motion of the object moving, which is always, again, smaller than the actual motion. An example of friction as well is also can be called drag or air resistance when it's falling from the sky. So now, when we're drawing free body diagrams, here in your notes, it gives you basic steps as to how to draw your free body diagrams. So again, I'm not going to read this for you because you can read this, but I do want to show you an example. So here you have a picture. And then you show here that the pulling of the rope is the tension force. And then the person, as he's pushing off of the cliff, this is the normal force is the force that is pushing perpendicular off of the cliff, and then gravity is pulling him down. So here actually shows all the forces acting. This is actually the free body diagram that shows all of the forces acting on the man, whereas how it goes from the picture all the way to your forces.